Alright, good day everybody, and this is just a short video explaining some of the algebra 3 simultaneous equations, the substitution method. We have 1, 2, 3, 4, 5 questions here. We already did one in class last week, so in this video we'll just go through them nice and quick. We could see here that we have the first question on simultaneous equations. Negative 3x minus 8y equals 20. Let's call that equation 1. And we have negative 5x plus y equals 19. Let's call that equation 2. Yeah. So I could see here that in equation 2 I have just the single y. So that might make it easy for me to just throw over the 5x. So from equation 2, if I throw over the 5x, I'll just have the y alone over here equals 19 plus 5x. So now that I have something for y, I could take this and sub in equation 1. So we could see in equation 1 we have negative 3x minus 8y equals 20, and of course I have something for y over here, so anywhere I see y I'm gonna put this. So now I'll have negative 3x minus 8y, which is 19 plus 5x. And that is equal to 20. Remember, the reason why we do substitution is now we only have one unknown, which is x. So now it's a little bit easier for us to solve. So now let's expand the brackets and see. We have negative 3x. We have this negative 8, and be careful with these negative signs. Negative 8 multiplied by 19. So 8 by 19 gives us 152. Wow, so that would be negative 152. And then we have the negative 8 multiplied by 5x. 5 8s are 40, so that'll be negative 40x, and that is equal to 20. Yeah, so now we just try to simplify. So negative 3 minus 40x will give us negative 43x minus 152, and that is equal to 20, right? So now we can say, well, let's throw over the 152. So negative 43x is equal to 20 plus 152. Negative 43x is equal to 172, of course, and therefore x is equal to 172 divided by negative 43, and that gives us negative 4. That seems like a pretty cool answer. So now we could take x is equal to negative 4 and sub in any one of the equations. Let's sub in equation 2. Right? We could see here that we already manipulated equation 2. Remember, this and this are the same thing. We just basically threw the 5x. So I could substitute y is equal to 19 plus 5x. That came from equation 2. And now I could just put x being negative 4. So y is equal to 19 plus 5 into negative 4. Y is equal to 19 plus 5 4s are 20, so that'll be negative 20. Therefore, y is 19 minus 20. Y is negative 1. Therefore, when x is negative 4, y is negative 1. And remember, when we solve a simultaneous equation, both of these here are actually lines on a graph. And this here is the one point where those lines are intersecting. That means that they are the one value for x and y that will satisfy both the equations. So let's check out this other question here. Negative 3x plus 3y is equal to 4. Let's call that equation 1. Negative x plus y is equal to 3. Let's call that equation 2. So we can see equation 2 is pretty easy. So let's deal with that first. So from equation 2, we could just throw the negative x over and we'll get y is equal to 3 plus x. And we could now sub this in equation 1, right? So equation 1 being negative 3x plus 3y equals 4. Remember, y is this. So wherever I see y, I will put that. Negative 3x plus 3y, which is 3 plus x. And that equals 4. So negative 3x plus 3 times 3, 9, and then 3 times x plus 3x, and that is equal to 4. So now we have negative 3x plus 9 plus 3x is equal to 4. And something seems really strange here, right? Because we have negative 3x plus 3x. Well, we know that negative 3x plus 3x is 0. And therefore what we end up with is 9 is equal to 4. And this makes no sense whatsoever, right? So remember what we were talking about in terms of the graphical solution is that a simultaneous equation is really two lines, and what you are actually finding is the point of intersection, right? Well, guess what? We came up with a very, very weird thing here. So this tells us that these two lines actually do not intersect at all. Yeah, these two lines do not intersect, and therefore this has no solution. Now let's see why the two lines don't intersect. And of course, the answer for this is no solution. This is undefined. They do not intersect, and therefore there is no point. But let's see why they don't intersect, right? Let's take each line and put it in the form y is equal to mx plus c. And let's see. So equation 2 is easy enough. Equation 2 would be y is equal to x plus 3. So we can see here that the gradient is 1 and all of that. Let's try equation 1. If we make y the subject of the formula, 3y is equal to 3x plus 4. Therefore, y is equal to x plus 4 on 3. What I did was I just divided by 3 to get rid of that y. So we could see here that both of these lines actually have the same gradient, right? Where the m value, m here is 1, and over here m is 1. And if two lines have the same gradient, then these two lines are actually parallel. And because they are parallel means if you solve them simultaneously, you will not be able to get any point of intersection. There just isn't any. So in this question, we actually have no solution. Of course, you didn't have to do any of this stuff. I just showed you so that you would understand what no solution means. But really, once you reach this point in the question, you could just state that there is no solution and you would be finished with it. For our next question here, we have negative 3x plus 3y equals 3. So let's call that equation 1. Negative 5x plus y equals 13. Let's call that equation 2. And from equation 2, I could see that I could just throw over the negative 5x. And we'll get something nice for y. So from equation 2, y is equal to 13 plus 5x. So now I could sub in equation 1, And equation 1 is negative 3x plus 3y equals 3. Right? And of course, I could just take this and sub it anywhere I see y. Right? So we could have negative 3x plus 3y, 13 plus 5x equals 3. Right? But before we even do this, we didn't really have to do this. Did you know that you notice that it have 3, 3, 3. So I could just divide by 3. So now I will have x, negative x, plus y equals 1. Yeah, divide everything by 3. And now it's a lot easier to substitute it in here, right? So now I have negative x plus y is 13 plus 5x is equal to 1. Right? So 5x minus x gives me 4x. 4x plus 13 equals 1. 4x equals 1 minus 13. 4x equals negative 12. X now is negative 12 divided by 4, which gives us negative 3. So now I could sub x equals negative 3 in equation 2, and I always like to use this one here because it's already in a form that would give us y. So y is equal to 13 plus 5 into negative 3. Y is equal to 13, 5 3s are 15 minus 15, which is negative 2, I believe. So therefore, and always state the answer when x is negative 3, y is negative 2. And given statements like this and making sure everything is step by step makes it easier for the person who's marking you. Yeah, it makes it easy for them to see and not miss any marks. We have our next question here. 6x plus 6y equals negative 6, and let's call that 1. I'll go with red for this one. And 5x plus y is equal to negative 13. Let's call that 2. So we could see again from equation 2, y equals, well, if I throw the positive 5x over, I will get negative 13 minus 5x. And of course, sub in equation 1, equation 1 being 6x plus 6y equals negative 6. Of course, I can divide by 6, giving me x plus y equals negative 1. And now I could easily substitute y in there to get x plus negative 13 minus 5x. And that is equal to negative 1. Right? So now let's just simplify. X minus 13 minus 5x is equal to negative 1. Negative 4x minus 13 is equal to negative 1. Negative 4x is equal to negative 1 plus 13. Negative 4x is equal to positive 12. X is equal to 12 divided by negative 4, which is negative 3. Right? And so now I could sub x equals negative 3 in equation 2. Y is equal to negative 13 minus 5x. Y is equal to negative 13 minus 5 into negative 3. Y is equal to negative 13. 5 3s are 15, and it'll be plus 15 because you have two negatives, this one and this one. Right? So y will be equal to 15 minus 13 is 2. Therefore, when x equals negative 3, y equals 2. And for our final question here, we have 2x plus y equals 20. Let's call that equation 1. And 6x minus 5y equals 12. Let's call that equation 2. We could see here equation 1 seems a little bit easier to manipulate this time just by throwing over the 2x. So from equation 1, y is equal to 20 minus 2x. Yeah? So let's sub that in equation 2. So sub in equation 2 being 6x minus 5y equals 12. I can't simplify equation 2 anyhow, I don't think so. So I'll just go ahead and make the substitution. I can see I might end up with some pretty big numbers here, right? So now I have 6x minus 5 into y, which is 20 minus 2x is equal to 12. Right? 6x is minus 5 2s are 10, that is 100. And 5 times 2 is 10, but it's plus because we have the two negatives here, negative by a negative. So plus 10x equals 12, right? So 6 plus 10, that gives us 16x minus 100 equals 12. So 16x equals 12 plus 100. 16x equals 112. X equals 112 divided by 16, which is 7. Okay. So now we could sub x equals 7 in equation 1. Right? Y is equal to 20 minus 2x. Y is equal to 20 minus 2 into 7. Y is equal to 20 minus 14. So y is equal to. So therefore, when x equals 7, y equals 6. And that's it for the simultaneous equations homework. We can see here that we have been focusing on the method of substitution, and there's a particular reason why I wanted you guys to focus on this, because we are going to have to meet simultaneous equations with quadratic equations sometime soon, and the method of substitution is the one you would have to use for that. So that is when you might have a quadratic equation, x squared plus 3x plus 5 equals 0, and then you might have a linear equation, x plus y equals 2, and you would actually have to try to solve this simultaneously, and this is where you might actually end up getting 2 values for x and 2 values for y, and substitution is what's going to help us out here. So substitution is pretty much a method of simultaneous equation that is pretty much really important and useful in a lot of different environments. Also, please remember, what you are actually doing when you're solving simultaneous equations is you are actually seeing where two lines intersect. And we saw in this one here how these guys didn't intersect at all because they were parallel, and so there was no solution. So I hope that you all understood this. Please feel free to ask me any questions in class, and I'll see you all in the next one.